Part two. So we've wired up the Taylor microwave switch here to the power supplies, which are giving minus 5 volts and plus 12 volts to its supply pins. We've hooked it up to...
No, other way around. Plus 5, minus 12.
Plus 5, minus 12, indeed. Thank you, Jasper.
Yeah.
Then, over here, we've hooked up the network analyzer to measure the transmission to the switch. It's currently at 7 gigahertz. And the pulse generator is then feeding a 0 to 3 volt pulse into the control port of the switch. It's also visible there on the screen. And we're starting right now with a period of 100 milliseconds. The IF bandwidth of this is set to 1 kilohertz so that we can actually see the switch turning on and off in the sweep. And now this is sort of the opposite limit to what we want, because in the end we want to switch super fast, way faster than the network analyzer can measure. But then what we should see is a modulation of the average power in the network analyzer. And so how's that going to work? So let's take this frequency. We're going to go to frequency mode, and we're going to go up to, say, if we go to 1 kilohertz, we're sort of on the edge. And now you can see our network analyzer is just on the edge of, in its IF bandwidth, being able to see the square pulses. You get these sort of little oscillations. And you can see right now this is a 1 millisecond periodicity, so it's already really slow. But we can go up to, say, 100 kilohertz, right? And now the network analyzer sees no sign anymore of the pulses, right? But the power is not the on power nor the off power. In fact, of course, it's exactly average halfway between. Now, if we go over here, then what we should see is right now the duty cycle of the pulse is 50%. And so that's why the average power should be exactly half of the power that it's outputting, or that it would otherwise receive. So the real test is if I change this power, this duty cycle, I should see the average power go up or down on the VNA, because that's the whole principle of the readout scheme over here, where we're just measuring the average power that's going through the gate flux. So let's see if that's going to work, which it does because we've already done this. But now, and it just makes sense. But let's just illustrate it. So now if I decrease the power to 40%, the duty cycle to 40%, then of course the power changes on the VNA. I go to 30%, changes again. I go to 20%, changes again. And then that's just where it goes. And of course if I go the other way, then it goes down the other side. This pulse is only limited, the square wave here is only limited to 20% duty cycle, but as we saw earlier with the pulses, we can go much lower. So that's all in principle good to go. And now the next step is to actually implement it with 2 switches and probably go straight to doing it with the qubit. So hopefully then we should be able to see T1 soon. That's all we got.